طيب السلام عليكم everyone. Uh, so we'll start today inshallah with our lecture with Engineer Laith, who's going to give you a quick tutorial on microwave office. The philosophy of the tutorial is to give you an idea how to use microwave office to build a particular circuit and simulate the output results of that RF circuit. And the way Engineer Life chose to do this is that he's going to go through steps related to your software assignment 1. So this way he serves dual purposes. He's going to give you an idea how to use microwave office, but in the context of solving a particular problem or analyzing a particular system, in this case, the system given to you in software assignment 1. And at the same time, he's also helping you a little bit with the assignment. In the future, we are not going to do something similar. So please keep in mind that today is your chance. If you have any questions, any queries, anything, utilize the existence of Engineer Life with us. And I hope, inshallah, it's going to be useful for everyone. At the end, after he finishes, inshallah, I have a few announcements that I have to, or reminders, basically, that I have to tell you. And then we'll do the attendance towards the end of the lecture, inshallah, through Blackboard. At that time, I will open Blackboard for sign-up. So without any further delay, we start with Engineer Life, who's thankfully here with us, devoting some of his time to support the activities of the course.
Assalamu alaikum, everyone. My name is Laith. Let me just share my screen. Okay, so in the assignment, you're given this paper and you're asked to recreate this system, right? Now, it might look a little complicated at first, but it's simply a low noise amplifier. It is biased and it's supposed to be matched. We're going to talk about those meanings in a bit. The main issue was you guys didn't have this component here, which is this subcircuit. We're going to talk through that. And whenever you get a task like this, where you have to design a system that involves an amplifier or whatever, the main component would be the MOSFET that you're going to use. In this case, it's the ATF54143. The first step is to go to Google and look up this amplifier. Now, sadly, this amplifier, if you want to model it on Microwave Office, it's obsolete. So there's no model for it online. But usually you would just look it up on Google. You would go to the website, the manufacturer's website, which is Broadcom, but it's showing here because it's obsolete. And you would download the file that would pretty much simulate this on the Microwave Office program. Now, in this case, it's not there. So what we do is we go to the data sheet and we take a look at what the data sheet says. This is the data sheet, which I got from Google. It's the first link. And if we scroll down to the page that I was on earlier, which is this page right here. One moment. You would see that there is a model here that looks a little too complicated. Now, not to worry, it's not hard to recreate this in Microwave Office. It's basically this circuit right here. So what you would do is you would go to schematics, new schematic, call it whatever you want. And then you would start putting the stuff that is here to the schematic. So in this case, we have an element called TLINP, which is here. So what you do is you go to components or element, you look up TIL, one moment. Oh, sorry, TL. INP, which is this one here. The description says it's a physical spec. and we take it, we put it in. As you can see, we have some parameters here, and all we have to do is just copy those parameters word for word from here to here, right? Same thing for the capacitor, inductor. We'll talk about those in a bit. And then the main component is a MOSFET. And this is the hardest part. So we're gonna get a MOSFET so you can see how it should look like in simulation. So it was the yeah, so it's this one, right? We double click on them to see the attributes, and we have a lot of them. And what we do is we go over here, we scroll up, we found those attributes here. As you can see, we have the VTO minus 0.3. We just put that here, VTO minus 0.3, and that's it. We do this for the rest of the things here. And then you're going to end up with something that looks like this. It looks a little complicated again, but it's easy, and this will be given to you. Now, in most cases, if you have a newer part than this, for example, it's not this, it's anything that is newer, you can just download the part and you would have this whole thing ready for you to use. You don't have to use anything. You don't have to do anything. Now you're asked in the task to recreate this system. Or this system already did it, so let's just remove the things. One moment. Yeah. So you will be given a file that has those two components in it. The subcircuit that we just spoken of, this one here, the one that looks a little complicated. So you'll be given that. It's a subcircuit. And as you can see, it also has some ports, right? So port 1, port 2, and port 3. And if we go back to the data sheet, you would see that those ports correspond to the gate, source, and drain. And this is how we chose those ports. So it's 3 ports, that's all you need. And we just click on sub. We have this here. Sub is basically sub-circuit. We click on yes, and there you go, we have it. We can change the shape of this however we want by double-clicking and going to symbol. I just chose a MOSFET because that's what they use in the paper. Now, moving on, let's start to recreate this whole thing. Now, this circuit is a biasing circuit, this lower part at least, and this here is the matching impedance part of the circuit. What do I mean by those? We can see that the port has 50 ohms, this has 50 ohms. Same thing for this, the internals, it's also 50 ohms each. So everything has to be at 50 ohms. Now, since we're talking about a signal that is, let's say, it can be an AC signal since it's it's an AC signal at a certain frequency, then we can't really do the math or the impedance. It would have an impedance, not a resistance. So we need to find the 50 ohms equivalent of this trace. So in this case, it's these two. This filter. Now it's not gonna work, and we're gonna figure out why later. So the first thing that we do is we start rebuilding the circuit. We can start by this part here. Since we already have this and this, we can start by the DC power supply. What we do is we go to the name, right, which is DCVS. We go to element, DCVS, and it's here, right? We can see that it's 5 volts. So we double click on the 1 volt here, which is the value. It's going to give us this thing, and we just click on 5. That's it. We also need a ground, so we're just going to go up and put a ground. Now we have a pi network that has 2 capacitors and 1 resistor. So we're gonna have to recreate that now. What we do is we go here, cap. It's good practice to lay out all the components that you need on this side, so you can just copy and paste them instead of doing this. And res, which is a resistor. And we also need an inductor, which is IND. So we start with the capacitors. Now, this mark here, this is the polarity of the capacitor, if it has a polarity. This one doesn't, so it's fine. This one doesn't really, you don't really care, it's an inductor. But in some components later on, you're gonna see it, and you should keep in mind of that polarity. So we have a 10,000 picofarad inductor, which we just changed this here to 10,000. And we copy it, paste it, put it up top, and it's 3.3 picofarad. So we do that, 3.3. Then the resistor is only 10 ohms, so we do that. You can rotate things in this program by right-clicking on the element and clicking on rotate. Then you just drag it down or up depending on the polarity that you want it to be, which is what I did here. So we drag this to its place. It's 10 ohms already, which is good. We drag this to its place. We drag this to its place, and we're done with this pi network. Now let's do this filter. We have an inductor 2.2 nanohenry. You also need to rotate that. And we have a capacitor, which I believe is 2.77 picofarad. And we're done with this side. We just need the grounds now everywhere. So like I mentioned, basically, this side, the lower part of the circuit, we care about it because we need to bias the, it's basically, this circuit has two parts or three parts, the amplifier itself, which is this one right over here. And then we have a matching circuit and a biasing circuit, right? So this whole thing is considered a matching biasing, matched biased amplifier. That's what it's supposed to be. And then we connect this to this directly. So we can just drag it, this whole thing to this side here, and we're done with this side of the circuit. Now let's move on to the other side, which is technically the same as this side. It's a carbon copy. So we have this capacitor, which is basically this capacitor, this inductor, which is basically the same value as this inductor. This network is the same as this network, but you have this Y network of resistors, which is connected to this part right here. And this is more like a feedback. So we start making those, and then we'll move on to the other parts. So we copy, paste, and then we copy, paste. We copy, paste. And copy, paste. Copy, paste. And then we have the network, the Y network. So it's pretty much like the one from power electronics or power systems, but it's it serves a different purpose here. One moment. Let's rotate. Okay. And copy, paste. Done. And then this part is connected to this part right here. So we just do this. And I think we're almost done. Just need to copy the values of the pi network. So the pi network has, the Y network. So it's 330 ohms, 10,000 ohms, and 1.2 kilo ohms. So 330, 10K, and 1200. And then we also need one more ground, which is here. And this is our circuit, basically. There's not much more to it than this. Now we're missing a couple of things, as you guys can notice. Where does the power go in? Where does it go out? So typically, you would apply some smaller signal to the gate, and it would be amplified on the output, right? So input, output, that's how it should be. Now the gate is the input most of the times because it controls the MOSFET. And then we would have some sort of a circuit. The current would flow through this way to the ground. If there's nothing here, if it's open, if there's a signal coming in, it would open, it would go to the ground. If there's nothing, then it's not going to. So we need some ports, some inputs and outputs to measure the performance of our system. And this is where we use the ports. This is a port input, and then we need another one at the output. Let me just rotate this. And that's it. So typically the signal would go in, right? Let's say the signal is at a 1 right now at some sort of voltage. So it's not a 0. It would go in, it would turn on this switch or MOSFET or amplifier, however you want to see it. And you would have some power flowing in, some higher power flowing in from this side to the ground, which would recreate the same circuit that is here. And yeah, this is how it should work. Now let's talk about how we can test our system or analyze the system. The first way is through graphs. Now we have a few parameters: gain, noise figure, and the S parameters. And the way you do those is you go to graphs, this folder, right click, new graph, rectangular, and you have something that is empty, right? You right click on here, which is graph 1, you click on add measurement, and then you can select which one you want. So in our case, we want, let me just close this. Yes, in our case, we want to measure the gain, right? Which is the available gain, GA. And we need to specify the inputs and outputs. In this case, our input is this one here, this port. And our output is this port. So it's from port 1 to port 2, from 1 to 2. Click on OK. We do the same thing for, also we have to specify which schematics, which is here, we're using. In this case, it's the full simulation one. And we click on OK. We do this step a bunch of times to get the noise figure, which is the minimum noise figure attribute, which is here. Same thing from 1 to 2. And then we go to, I think it's, oh, not stability, where was it? To get the S parameters, we, let me just remove this because we don't need it really. To get the S parameters, we need to go to, one moment. Yeah, port parameters, right? So it's you have 4 S parameters in general: 1, 1, 1, 2, 2, 1, and 2, 2. Depending on how many ports you have, it might be more. But in this case, we only have 2. S11, or the S parameters of 1, 1. It's basically port 1, 1. So it's from 1 to 1. It doesn't change. Same thing for the 2, 2. 1, 2 is 1, 2, and 2, 1 is 2, 1. It's pretty straightforward to set up. And right after that, you can click on Analyze, which is the simulation part. Click on Gain to see how it should look like, or how it looks like. Same thing for the noise figure. And the rest of the S parameters. I think that's it for this part of the tutorial. Do you guys have any questions that I can answer?
So in this case, we're doing the biasing using the voltage source inside the circuit itself, right?
Yes,
When
pretty
you're
much.
using an outside voltage source.
Yeah, so the biasing here, it's inside, not outside. I mean, yeah, that's pretty much it. Because like when you go to an actual system, a practical system, you would have this, you can actually buy this part. So this amplifier, if you went to the Google search, you can find that it's on DigiKey, and you can actually buy this. And this is what we're after. This is what we're trying to model here. So this doesn't come with a biasing circuit or anything. It doesn't come with a voltage source. So we're trying to do that here. Trying to add the rest of it. Now this whole thing can be a sub-circuit. And then you can add some things to it. Basically, you can add a signal on the input to see how it's going to perform, or to test how much. It's pretty much you can perform more tests if you could put this as a sub-circuit. And the way you do that is you create a new schematic. We already did that anyways. Let me just remove this. And you go to sub. You click on full simulation. And now you have a black box, which has an input and an output. This black box is basically this whole circuit. So now you can pretty much add further things to it if you want. But that's about it. Any other questions? Go ahead.
Okay, thank you very much, Engineer Laith. Please stay, so don't leave, because I need to encourage the guys to ask questions. So please note that if there is something that you don't understand, there is not going to be any other tutorial. So the assumption here is if there is anything which is not clear to you, anything that you think you cannot do because you don't understand how it was done, your chance is to ask questions today, okay? We might not have any other tutorials, and Engineer Life might not be available in the future to provide any further support. So please, if you have any questions, ask your questions now, okay? I don't need to remind you again. So please, any questions? Yeah, apparently my threat did not work. So anyways, it's up to you. So my assumption is if you don't have any questions and everything is clear, then you should be able to complete your assignment successfully, as well as future software assignments using Microwave Office. Since you don't have questions, means that you probably understood everything. So,
Now,
okay.
I'll explain one more thing, Professor, if that's okay.
Okay, yes, please, go ahead.
So in the same paper, right, and you're probably going to have to do this as part of your course curriculum, basically they give us this circuit, which is the same as the previous circuit. It's exactly the same. This is the MOSFET. It just looks different. But instead of the LC filter that we had here as a matching circuit, they're using the microstrips, right? They're using microstrips here, basically traces on the PCB, or silicon-based microstrips, whatever it is. Now, this is another way of matching the impedance. So we have 50 here. We also have 50 at this input. This has to be 50 as well. And if you do the math here, you would find that it is indeed 50. The way we do this in Microwave Office is that the same thing, we go to the component name. So over here, it's MLIN. We go to elements, MLIN, and there you go. This is a microstrip line that has some parameters. We just copy those parameters letter by letter, and that's about it. Now there's this parameter here, which is called M sub, and this M sub relates to this here, which is a microstrip subcircuit, substrate, sorry. Here, same thing, MTEE $. It's not an S, it's a $. So MTEE $, which is this one here. Same thing, it has some parameters, which is this one here. The M sub goes to this. And yeah, that's about it. We just copy those things, and you would be done with modeling a circuit that looks like this, as long as you have this part, which is the most crucial part, that has pretty much all the parameters that you need already embedded in it. Any other questions? Any
Yeah, quick question. What about this? I'm assuming it's a microstrip, the M sub.
yeah, what about it?
What exactly does it do?
It defines the properties of the microstrips that you're gonna pretty much be using.
Oh, okay.
Right, so if you go here, so for the rest of the students, so microstrip. So if you've ever seen a MOSFET or a silicon chip or anything, even the communication part of things, the PCB, the communication, sorry, the high frequency or high speed PCBs, you would find that it has a lot of weird looking traces. And those traces are basically, this is the basis of those weird looking traces that would function as capacitors or inductors to do some matching circuits. So it's basically it's like a PCB layer kind of thing. So you would have copper on top and bottom. The top one is usually transmission line, the bottom one is a ground one, and you would have some sort of substrate or dielectric, right? Which can be aluminum, it can be fiber, it can be glass, fiberglass, it can be a bunch of things. This tells us the properties of that substrate. So what is the dielectric constant, height, and a bunch of other variables and properties. I hope that answered your question.
Yeah.
Okay. Any other questions? Dr. Tamer, you need to threaten them again.
Just one quick question. We're expected to use the microstrip matching, right?
Yeah, not now.
Okay.
Not at this stage. What you're expected to do is simply this, the circuit that you see in front of you. That's it. You'll be given the you'll be given this here, the MOSFET, or the amplifier. You're also going to be given the properties for the microstrip to make it easier for you guys, but that's it. You're going to have to do the rest. And all you need to do is just simulate, get the figures, and save them for later use. That's it.
Perfect, thank you.
No worries. Any more questions?
All clear.
Okay, good.
Here, mashallah. Okay, good. Thank you very much, Engineer Light. Just for all of you, quick reminders / announcements. The deadline for the assignment has been extended towards the end of this week. So you have a few more days to work on your assignment, the software assignment that I'm talking about. So please try your best to finish that successfully. The upcoming software assignments might be a little bit more challenging. So this is your chance to get a full mark on this one, especially with the tutorial and everything. Also, I have posted the 3 tasks required in your project, task number 1, task number 2, task number 3. You don't have to work on these in series. So you don't have to wait, for example, on task number 2 until you finish task number 1. You are supposed to be studying the whole material from the book. But as the groups have been defined, every 3 groups are going to do a certain sections from the chapter. So please work out your presentation. The deadline for submitting your slides of the presentation is already posted on Blackboard. So before that deadline, make sure that you submit the slides. Also, a few days later, there is the deadline for your selected voltage controlled oscillator circuit that you will simulate. As we discussed, you need to pick one from outside the book, so not from the book, from references outside the book, and as individual groups. So each group by itself have to pick a circuit, uploaded to the assignment task 2, and submitted. You have 4 chances for submission. When I look at it, if it's approved, then your submission is done, and you will get a notification that it's approved, and you are done with that task. If it's not approved, I'm gonna give you a feedback, asking you, telling you why it's not approved, and asking you to look for an alternative. It's better to start this task as soon as possible. Don't wait until the last minute, so you will have the chances to submit and get my approval and so on before the actual deadline for that one. And then last but not least is going to be to simulate that circuit that you have chosen and produce the 2 pages report as per the guidelines given in your description of the project. Okay, so the earlier you finish task 2, the earlier you can start task 3, and then you will have more time to do your simulations. If you face problems, you can come ask questions, can provide you with support so that you successfully finish all the 3 tasks of the project. Okay, when the presentations are gonna happen, this is something else. I'm going to announce that later. But more important for you now for task number 1 is to submit the slides that you are gonna use for your presentation. As mentioned, you can choose the mode of the presentation, whether you'd like to do it, each one of you is gonna take part. Some of you only are going to be chosen by the group to do the presentation, or even a single person. It's your choice. The grade for the presentation is going to be 1 grade for everyone. But then in addition to that, as part of the presentation part, I'm going to ask each one of you an oral question. And based on their reply, they will get their individual grade for that particular task, which is task number 1. Okay. So there is like a group evaluation based on the slides and the presentation itself. And there is an individual evaluation for that task, task number 1, for each one of you based on answering the questions. Okay. That's it in terms of your project. There's going to be a new software assignment posted soon. So you will enjoy doing that assignment during your Eid break, very long break, 10 days. So you have to do something so that your brain doesn't stop working.
You're gonna enjoy it. Yep.
Yeah, so you have to enjoy it by doing some more software assignments. And also, a couple of quizzes are coming to us. They will be online quizzes as well, a quiz on assignment 1. And when we have the end of assignment 2, you will also have a quiz on that assignment. And the midterm is coming very, 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 very soon, right after the break. I will announce the time, the mode of the exam and everything in a couple of days. So you will know exactly when is your midterm, and you will know also how it's going to be carried, what's required, and so on. That's the first, I mean, I don't call them midterms, I call them mini exam 1, and then there is another mini exam towards the end of classes of this course. Okay, these are the announcements that I had to do. Any questions about the announcements? But please make them brief questions. Don't ask about things that will be announced in the future. You will know about them in the future. If you have questions about the ones that I explained clearly now, you can ask them. Otherwise, we can go for the attendance.
Just Dr. one quick question regarding the splitting of the groups and which groups will be together and which topics they will take. When will it be announced?
It's already announced on Blackboard.
Oh, okay, perfect. Thank you.
So each sections and who are the groups that are supposed to join forces to do the sections is already on Blackboard. If you go for task 1, you will find in the posting of the assignment, it's already mentioned there. Section 1, section 2, both of them goes to this and this and this group and so on. Okay.
دكتور
Yes.
بالنسبة للسيميليشن هاي per group ولا كل واحد بروحه؟
لا, individual. Simulation software assignments in general are individual. Only projects are group work.
ويا ريت دكتور لو ترفع الريكوردينج حق اليوم علشان يعني إذا في حد يراجع أو شيء عرفت.
حاضر. I will try my best. حاضر. No promise of recordings, but I will try my best.
شكرا.
This session recording.
Huh?
This session.
Yes, yes, I know about this session as well. No promise of recordings. I didn't promise recordings. We did record the session, but it's up to me to decide to upload it or not. Okay يا شباب.
طيب دكتور, how many slides are we supposed to do?
It's up to you. See how do you want it. So you are describing a class to your colleagues, so it's up to you. 2 slides, 10 slides, 15, 20. You will be graded based on the clarity and the slides.
Doctor, one question, please. Regarding the dividing between each group, like a minimum of 1 person per group need to be presenting correctly?
No. When you are doing task number 1, the 3 groups are dealt with as 1 unit in terms of the slides and the presentation. I mean, you can choose even 1 person from the 3 groups to present. It's up to you, okay? But then this is part only of the evaluation. The other part is going to be individual questions to each single member, okay?
Okay, clear. Thank you, Doctor.
Any other questions, يا شباب?
Doctor,
No.
regarding the question for each individual, are we expected to know everything about the section given to us?
Not the section given to you. You are supposed to know everything about all the sections.
So
About
from
related
8.1 to
to-
8.5.
Yes, from
Okay.
from 8.1 up to 8.5. So you are supposed, because as I told you, every one of you is supposed to study that. تمام? However, when it comes to presenting, there are certain allocated presentation tasks. Okay.
Okay, thank you, Doctor.
Any other questions? طيب يا شباب. I will open now the attendance so we can do the attendance for today's session. Just give me a minute and Blackboard will be open. And meanwhile, also I'll capture the names from here. So don't leave until the Blackboard is enabled and you can do your attendance.